there we go. Now we are live on YouTube. Cool. Well, not live because we're not streaming. I did try that sometime, but that did not work out well. But at least this will be recorded, so you can watch it for posterity when you're older and you want to get the flashbacks of 202 or something. So yeah, okay. So let's talk about what we talked about last time. So we did some review of C++, and then from there we introduced the concept of function overloading, right? So we said like, okay, we got two functions that have the same name, the same identifier, so like foo. However, they either have a different number of parameters, or if they have the same number of parameters, the parameter types are different. You cannot have two functions that have the exact same name and the exact same parameters with the same type, because then you get an error. But as long as there's at least a variation in the type of it, so like you got something with an in, another one has something with a double, then you're okay, right? And that's pretty much what we spent talking about last time. I don't think we started talking about classes, so that is what we're going to be talking about today. So let me just make sure that we can all read this. I don't know why it shrank. There we go. And let's just make sure that it still runs. Yep, still runs. Okay, so we'll leave that ready to go in case we need it. However, let us go ahead and start with a couple of concepts, okay? So, what are classes? And why do we need to learn them? And what is object-oriented programming? And why is it a good thing to do? Okay? The second one's a little bit trickier to answer. But the first one is because you have to, right? Now, it turns out that when you're coding, it's a good idea to contain data in some sort of structure, right? And so in 135, what that means is like, you know, one of the last assignments you do in that class is something around the basis of like, okay, you have data of different types, so like some integers, some strings, maybe a double in there, and you're trying to associate all that data with something. So like, for example, you might have done an assignment where you have a list of students, and that's each student has like basically like a name, a student ID number, maybe like a grade or a class list or pay, something like that. Like you all did it. And feel free to on the chat to jump in and tell me what like some of your final assignments in 135 were, which probably if you all took it last semester, you all have the same one, right? Or maybe financial records, right? You do these kinds of sort of pieces of information that are bundled together, right? And you use structs for that. And structs are cool. They're great. In fact, the way you're using them in 135 is more of like the C style struct than the 202 class style, because it turns out the structs and classes are actually identical in C++. If you use a struct and use a class, they're the same. There's one tiny difference which has to do with public or private. I don't know if I'll get to talk about public or private today, but if not, I'll probably talk about it on Wednesday. So don't worry about that piece. But for all intents and purposes, it's the same. So yes, very good. Yes, indeed. Structs are public and classes are private by default. But you can change that very easily. But again, you know, we'll leave that away for a minute and then we can come back to it. I think actually we want to talk about it today because we kind of need to set things to public so they compile. But, oh, yeah, they do. Great. Well, that's even better. Hopefully you all went over the differences then. So that makes it easier. I'll still go over it just in case, but yeah, good. I'm glad you guys are ahead of the curve here. Okay, so let me give you a formal-ish definition of what a class is. So a class is going to be a collection of, I guess, let me lowercase that, of a fixed number of components. Now, components can be one of two things. They can be methods, also known as functions, although those names are, depends on who you ask, they might be interchangeable. I tend to think of methods as a function that's in a class, whereas a function can be just like a global function. But, and then things like Java, that's kind of what they do, but some languages, they just use function overall, they don't use the word method, so it depends on who you ask, okay? Just remember, there are going to be functions inside of a class. And then, of course, your variables which sometimes people say fields, I think. When you take compilers or when you take 326, which is the programming language class, they'll go more where like what these names actually are and whatnot. Okay, but just think of it like variables and functions. Okay, that's going to be the easy one. Okay, so if structs and classes behave identically, why do we have both? That's a very good question, actually. C++ is backwards compatible with C for the most part, which means that if you know the C programming language and you're trying to like learn C++, you don't really have to learn a lot because everything will work except for like some special cases. And so it turns out that when they were developing C++ and they wanted that backwards compatibility, they said, we have classes and they're so much better than structs, etc., but we're still going to have the keyword struct in there for the C people, and so that the C code runs. And so that's why they kept it, basically, just for backwards compatibility. But you really shouldn't be using it. Again, it's unfortunate the way that they teach the 135 class, that you're learning a struct as like the C. In fact, I would say that like 99%, well, not 90, maybe like 90% of the content, because EO-manip is not, but other than EO-manip, most of the things you learn in that class are C. Like, you're not learning C++, you're using C. Like, outside of Cout, Cin, and like the IO-manip stuff, everything you're learning there is like C. Like, you're using C++, but like literally you could go and code on C and it would all work. So it's almost so the question. So somebody asked the question for those of you on YouTube. So is C essentially a subset of C++? The answer to that is almost, because for it to be a subset would mean that it would have to include all features of C and C++. But there's some edge cases of things that don't work in C++. So there is some code in C that wouldn't compile in C++. An example of that, I think void pointers are not very cool in C++. And there's some things you can do with memory that the C++ is not like, I think. But you could probably Google like C and C++ differences, or what will compile in C and not in C++, and find a list of them. But they're very tiny, and like you wouldn't run into them on a regular basis, basically. The idea, they really wanted people to like move on from C to C++. So that's why they did that. That was the easiest way to get people on board, basically. So, but yeah, that kind of goes back to the original question as to the struct, okay? But yes, if you know structs, you already have this idea of being able to have different variables that are contained in one struct, right? And that's the same thing with a class. You have different variables that we contain in one class. But in addition to that, and it turns out you can do this with structs too again, but again, you don't really do it because in C you wouldn't, is functions. You can have functions inside of these structs, which will not, in fact, I'm going to stop using the word struct, I'm going to use classes now, okay? But yeah, we can have these functions inside of a class, okay? And so what you're creating is kind of like a tease of what you learn in 302, which is like an abstract data type or a data structure. And that's the idea of having an object that can contain data and operations that can be done on that data, okay? So basically, what you're doing when you're doing object-oriented programming and you're using classes, that's what OOP stands for, by the way. Let me write that down since that's important. Object-oriented programming, okay? That's what OOP stands for. And so when you're doing this, the idea is that you want to create an object, and in that object, you want to store data and operations. And what are the operations of? They're operations on that data. Okay? So you're both operations and data, and the operations are actually for the data. So things like, let's say that you're creating a clock as a program. Okay, so like let's say you're making a program that is like a mini clock, and so your variables would be things like the second, the minute, and the hours. In fact, you could do it all in seconds, but let's just say you're making it easy. Okay, and we have a calendar too there, so you have like month, day, and year. Operations on that data might be things like increment, so like increment a second, or increment a date, things like that. So those will be the operations. So we have a question. What is the name of the style of programming we were using before object-oriented programming? I believe the way you code in 135 is called empirical. I think it's empirical programming. I think. Let me Google that because I might be missing. It sounds like imperial or something, but let me triple check. Empirical programming. That does not sound right. Maybe it is. I'm not sure. Imperative. Yeah, it might be imperative. Thank you, guys. There you go. Yes. See, it sounded kind of close to imperial. I was thinking Star Wars for some reason. Imperative. Yeah, that sounds much more like it. In fact, I think they do tell you that in 135, but let me just Google it now. Yeah. Yep. Imperative. Thank you, guys. Appreciate it. So yeah, imperative. Okay. So it's not to say that OOP isn't particularly a form of imperative, but that's just sort of like the generic view. Okay. So anyways, going back to object-oriented programming, it's this idea of just trying to contain all this code into objects as much as possible. In fact, like super like insane. Like literally, you want to make everything in your programs be objects to be like a purist of object-oriented programming. You don't want to have global functions, you don't want to have global variables, and you don't really want to have any code in main. All you want to do is just make classes with functions all in classes, variables all in classes, and everything is objects. If any of you are familiar with Java or C#, that's pretty much what they do, but particularly Java. Like, you just make everything objects. Even calling the print function is an object. Like, you just happen, like main, like, is literally just to start other objects, okay? So, yeah, you just have to get into this mentality of making everything classes. Now, why would you do this? You should be asking yourself, like, why? You always should question when people tell you to do something, especially when they tell you that it's a better thing. And so, you should be questioning, why is this better than what I did in 135? Is this the last C++ class we take? Yes, because in 302, while you do C++, you don't learn any C++. You just expected to use what you learn in this class and then 135. And then when you do 326, you do Java. And in Java, like, well, actually, it depends on who you take it with. But if you take it with Peterson, Dr. Peterson, or Ben Cisneros, or anybody that's not Dr. John Minor, it will be in Java. If it's Dr. John Minor, then it will be in a plethora of languages. Now, 302, I teach 302 often. I don't know when or where I will teach it again. They don't tell me these things. This is like, I find out like last minute too. I literally find out when you guys find out. So yeah, it's only when it's like the special classes like data analytics class I'm teaching that I actually know ahead of time. But for these core classes, it's like, I don't know. I frankly have no clue what to do. I feel like they just literally throw classes and like names and then just like draw names and they're like, yep, he's gonna do this. Like, GG. So yeah. But anyways, going back to this, you wanna, the reason why you wanna do this and why it's good for you is because by containing everything in classes, it allows you to reuse code a lot more. It allows you to expand upon code. We're going to learn probably next week about inheritance. And inheritance is the ability to take code that you've already written and expand its capability. So add new operations or add new data to it. And so it really opens itself to code reusability. And it also contains the code to make it more readable. We'll be writing code that's more readable and shorter, which also makes it easier to debug and to work with. Okay, so these are some of the pluses of object-oriented programming. But I think the biggest plus is the fact that it allows you, when you're designing code, to think about a solution that makes sense to us humans. So for example, if you're doing a car and you're doing some code for like a car, your code might look like car.startCar. And you know that that function is going to start the car. And which car is it going to start? The car that you call it on. So like for example, let's say you have a car class. And we'll make an example of that. In fact, that might be a good example to do the car class. So we'll make a car class, right? And ultimately, if we want, what are things, some of the operations that the car needs to do? So that's how you start thinking like this. Like, what are the operations that I need to do, and what's the information the car needs to contain? So let's actually do that right now. So some of the operations that you want to do is you want to start the car. You want to stop the car. You want to accelerate. I suppose you want to be able to brake. And maybe like lock the car. And then of course there's a lot more things you can do with the car, but this is probably enough of them. Okay, lock as in like lock, unlock doors. Okay. I guess steering is also good, so this might be that. But yeah, so those are the operations. In terms of data, well, you want to keep the speed of the car since you're accelerating and dealing with that. You want to know the status of the car, whether it's on or off. And then I suppose you want to know the status of the door. Since you have the ability to lock and unlock, you want to know the status of locked, unlocked. And then, yeah, that's enough for this. Of course, there's a lot of other things, but that's what you want to do, right? So this is very like somebody who has never programmed before, who comes to you and says like, yo, I want you to write some code for like representing a car. They don't know any programming, but they can definitely answer to you what you want the car to do and what information you want it to contain, right? And if not, you can create that information based on what you want to do, which is kind of what we did. We have a question. Is there another more advanced style of programming after object-oriented programming, or is this like the industry standard level of coding? So as much as I am telling you right now that object-oriented programming is amazing and great, not everybody agrees with those statements. Some people will say that it's trash and that you should never use it. But at that point, it's not like a consensus. There's a lot of people that love it. And there's a lot of people that don't. So ultimately, it's going to depend on where you go to work and what language you use while you're working. The other big doctrine of programming that is popular is functional programming. So functional programming is a completely different style of programming. It looks like if you were just writing everything in functions. So forget classes, they don't exist. Now you're going to make everything in functions. Like everything should be function, calling the function. And there's no states. So like there's no variables. There's no, all you can do with functions is like modify things and return something. You can't save things outside of that function scope. It becomes very hard to think about, but it does have its advantages. And it's all recursive. So when we talk about recursion, we can revisit that concept. Okay? What does it say to the left of speed? Data. So let me rewrite that. So yeah, that functional programming is something. Some companies will use it, but unlikely for big things, unless you're working in like some research thing. And yeah, there's other like sub-doctrines of coding, but they're going to be based more than likely on classes and things like that. So a lot of places will use this OOP approach than functional. And within that, there are other sort of doctrines that handle other parts of the project other than just coding. When you take CS 472, which is the senior design class and also the class known as software engineering, which is required for CS majors, they'll talk about that kind of stuff. So yeah, so you'll know more about it, but you really have to learn all the basics before you can get to that level and sort of like have an opinion of like, oh, you know, functional is better, or you know, I want to use DOS. Like there's a lot of things. I don't want to bring any names and confuse people, so that's all I'll say about that. Okay, so yeah, so you have operations and data, right? So this is how you think, and this is very easy for someone that hasn't programmed to think about it this way. Think about what they want to do and what they need to do that, okay? And so that's what really, really makes this as appealing to people, to be able to convert ideas into code. So let us go ahead and actually create a class, okay? And then we'll do the car class. We'll do the car class on the computer because we will code it. But first, let me give you the basics of the syntax of how to actually declare a class. It's identical to structs, but it's still good to go over that. So to do it, you go ahead and you write the word class, like you would struct, and then you put an identifier. So this is my fancy way of saying identifier. Okay? And then there could be other things in here, but for now there won't be because we're not doing inheritance or anything. You put a curly bracket, and then you're going to have some stuff in there. But when you finish doing the class declaration, you put a closing curly bracket and a semicolon that I will guarantee you I will forget to put today when we write the example. Okay? So don't feel bad if you forget yourselves. Okay? This identifier has the same rules that identifiers have in C++. So A through Z, no 0 through 9 in the beginning character, but after that you can do them. You could also start with an underscore. Okay? So as you can see, this is like literally you could replace this with struct, and that's what you did in 135. Okay? So that's all the same. Does it start with capital letters? The word class? No, it starts with lowercase. As for naming conventions, you're free to choose anything from A through Z, uppercase or lowercase, or underscore. However, I think it's a good practice to use uppercase for class names. I personally do that, so you probably saw that in like the first assignment that I was doing that for the unigrams. So yeah, I would say you should do it, but you're free to choose your own naming convention. You can still use camel case, but I just like that to use the first one as uppercase. It kind of in my own personal brain, like it sort of tells me like this is a class versus like this is like an integer. Yeah. So yep, I recommend you take that, but I don't want to like insist like that stuff because that's personal. You know, you might choose to do something else. I don't want to force you into my habits that are strange or something. So yeah, so once you have it in here, there's a couple of things that the class needs to contain. Actually, no, this compiles as it is, but its class does nothing. You're like, why would you do this, right? So there are some other things that you can have in here, and those are going to be your functions, which usually have return type, and then the identifier for the function, and then your parameter list. Like that, okay? So this literally could be like void foo blah, okay? This identifier can be anything. However, do not make these to be the same, okay? No, don't do that. If you do that, it's a special case that we're about to talk about, okay? So this is just an example of a function or method in a class. And then, of course, variables are going to be the same thing. So you're going to have the type followed by an identifier. And yet again, in this case, you definitely do not want to make that ID be equal to either the green one or the red one. Okay? So, variable. No semicolon after the functions, okay? No semicolon there, but semicolon after the variables. And you're gonna have one or more. Doesn't matter how many you have, okay? The ordering doesn't matter either, okay? And for now, again, we will talk about why this is the case. For now, just so the code compiles, you wanna put the word public followed by a colon like that, okay? However, that's optional. So I'm going to erase it, but it's just a tease. So that will come, okay? Would you initialize the variables in the class like in main? You can do that, yes. However, there's another place for that. In fact, that's a great question because it will segue into what a constructor is. So yes, you can do this. What's the color I have in here? It's brown. Actually, technically, yeah. That's optional. However, if you do that, you gotta make sure you use C++11 or newer. Otherwise, you get a compilation error. So you can initialize things like this. I believe it's called inline. No, inline is something else. But you can initialize your variables as you declare them. But only if you're compiling with C++11. So that's like when you do std equals C++11 or 14 or 17. However, you know, it might be by default compiling with that, in which case you don't even have to worry about putting it in. But I'm just making you aware, because if you run into a situation where they're still compiling with C98 or older, then it won't compile. So yeah, but CodeGrade allows you to compile with newer ones, so you can do that. Okay. But still, how would you do it in the past before this wasn't a thing? Well, this brings us into a special function that you're going to have, right? In the past, you have learned that functions can be value returning, but they can also be void functions, right? Well, now we're going to discover this new special function that technically is not value returning and not a void function. This is known as the constructor. So what's a constructor, you ask? Well, I'm glad you asked. A constructor is a function that only runs, it's part of a class, so it has to be part of a class, and it only runs when the object is first called. So let's talk about how you declare a variable of a class. It's the same as a struct. You know, in the struct you say like struct a, or in this case it's called whatever. Let's do, we're going to use car. So let's say you do struct car, then you say like Toyota, and then that's your variable name, right? So that's how you would declare that. For a class, it's the same, but guess what? Actually, you don't even need this for struct. You don't need to put the word struct in front of it. That's a C thing, actually. In C++, you don't need it. You can just, if your class is called car, then you can just say car and then put the identifier. And same thing for a class. You need to put the word class in front. In fact, I don't even know if with the word class it'll compile. It might, but either way, there's no point. It's too much typing. So the way you do it is you're going to put in your class name, followed by your identifier. And you want to make that identifier unique. And you can also make an array, by the way. Again, don't worry, you'll see actual code examples of this in a minute. I'm just going over the basics here of like the syntax. Okay? This class name should literally be the stuff on green. In fact, I'll just highlight it with the same color. Technically speaking, since we're doing markup, I should say ID there, but I don't want to confuse you. Okay? So that green and that green match. They are both literally supposed to be the same thing. Okay? So that's how you declare an object. And an instance of a class is known as an object. In fact, that's important. Let me put that in here. Definition of an object. Okay? Also known as instantiation. So when you instantiate a class. Okay? So an object is an instance of class, which means you're actually making like an instance of it. So basically you're making one real thing that contains the data. Okay? So when you do that, when you create that, or when you're doing dynamic allocation, which we'll talk about in a few weeks, but don't worry about it. But when you actually do this, so if you have a class called car, you know, you uppercase it like me, and you actually want to make an object of this class, you want to instantiate it, you might say like car Toyota, right? When you do this, this magical function that I was mentioning called constructor is going to get called. And its purpose is simple. As you noticed, this class could have functions and variables, right? The data part. It's convenient to initialize things when you start up an object, right? Like set the car speed to 0, set the car status to off, set the doors to like unlocked or locked. And so before C++11, where you could do this like right here with the brown, it turns out that you would use a constructor for that. And that's where you would do all of your initializations. So how do you make this magical constructor? It's not that hard. I'm not going to put it in here, but you know, it would go somewhere in the class, okay? Geez, I have like 50 different emails. Scary. Okay. The way you do a constructor is if your class is called potato, then your constructor is going to be called potato. So you always, put as a note, always name your constructor with the same name as the class. Okay? So let me just copy and paste this top part. Okay? So if I want to make a constructor for this, I would take whatever ID is equal to, throw it in there, put some parentheses, and code away. So the code you write in here is going to be run whenever you declare an object of the class or you instantiate it. Such as setting your values to 0, initializing stuff, dynamically allocating stuff, which we'll talk about in the future, and so on. It's very useful. And again, it was the only way that you could initialize things before C++ 11. So that's what a constructor is. As you can see, there's nothing here. There's no void, there's no return type, nothing. And you don't write return here either. Well, I mean, you could, but you wouldn't. You shouldn't. It doesn't return anything. It's a special function, okay? You can't have parameters in here, by the way. So you can list parameters there. And if you list parameters there, when you create your class, such as this, you could actually put them in there. So you could say, like, let's make another one called car. This one's going to be Dodge. And then you pass them like a value there. This value would actually go into the constructor. Why is it good for? Well, like let's say that your initialization is actually what you're passing as a parameter. So maybe this Dodge, you're passing in the year of the car. So you pass that in the parameter there, and then you can set a local variable to that. And that you can't do with the brown example here. This one you can initialize if you always initialize the same thing. But if you want to initialize based on the parameters, you have to use a constructor for that. Very good question. So we have a question saying, are constructors required for class to compile? No. It turns out that C++ has a default constructor, which is added to a class if you don't provide a constructor, which allows it to compile. And by default, I'm saying it happens behind the scenes. It doesn't just like magically appear in your code. All it is basically like an empty one. So like imagine like there's nothing in the parameters and there's nothing in the body of the function. Okay? It just happens to be there. In addition to being a constructor, there is another special function called Destructor. This one is not as exciting, at least right now, because its main usage is when you're dealing with dynamic memory allocation. However, I still would like to point it out to you now in case you run into it on the internet. And you're like, what is this? So the Destructor, I can actually put it on this example up here. It's another special function that runs when the object goes out of scope. Okay? So special function that runs when not and, but the object goes out of scope. Okay? Another example of that is not just when it goes out of scope, but when it gets deallocated. But again, we haven't talked about dynamic allocation a few weeks from now. I like to tease this just so you know that there's more to this, but you know, yeah, that's all I'll say. So what's it for? That one again it's more useful again with dynamic stuff. But like it can have some uses in other scenarios. In fact, let's say that you would like to open a file in your constructor because it could be something useful. You could then close that file in the destructor. Okay. You could also use the destructor to send out like write some logs out to files if you're using logging, or to do some like wrap up things that you might want to do to the class, like reset values before it goes away. Although that wouldn't really have a good usage, maybe like for like pseudo security purposes. But yeah, like I said, it's not very popularly used for anything other than memory stuff, but it exists, and it is definitely going to play a big part once we do get to the dynamic allocation. So let me just show you very quickly what a destructor looks like. Well, it turns out that it looks identical to the constructor in its syntax, with one difference, and that is the tilde symbol in front of it, like that. So as long as you put that in there, this is now known as a destructor. And then you can only have one, by the way. You can have multiple constructors, by the way. I didn't mention that. That's very important. Let me put that in here. Did I ever define what a constructor is? I didn't quite officially define this. Let me put it in here. Special function that runs when a class object is instantiated. That's, I ran out of space, so here, I'll just bring that down here. Okay, that way I can get rid of that. Okay, so a constructor is a special function that runs when an object is instantiated. The destructor is a special function that runs when the object goes out of scope or is deallocated. Okay, why is it good to close a file? I noticed that I forgot to do it in the homework, but it didn't cause any bugs. So in theory, if you don't close a file, there is overhead by the operating system that holds that file hostage, in the sense that I forgot what they're called. They're like file descriptors, I believe. So there's a limit of them, probably a really big number, but in theory there's a limit of them. And if you don't close files and you open like 1 million files, you might actually hit the limit, and then the thing will crash. So that's one usage of why you should close files. In theory, C++ should release all of those things when your program terminates. But then again, when you're writing code in the real world, you're probably not writing the beginning or the ending of a program. You're just writing some piece of a program that's actively running. And so it's a good idea to clean up after yourself, to not like contribute to memory leaks or other things that happen when you don't clean up code. And so that's why we want to kind of encourage you to always do things like clean up after yourself. So close your files and things like that. But in theory, the operating system should be like, okay, this dude forgot to close his files and the program ended, so I'll just terminate it all. And the same thing with memory leaks, right? Memory leaks, which, well, we haven't talked about them yet, so I cannot assume that you know it. But like with memory leaks, when we do talk about them, it's the same deal. So like if a program terminates and you still have memory leaks, the OS will release it all. And that's why, like, if you're playing a video game and it starts to get slow because of memory leaks, restarting the game fixes it all. So, yep. It's a good question, by the way. I like these questions. These are very, very good because they point things out that I might forget to mention. So, it's good. Okay. So, that's Destructor and Constructor for you. Again, the Destructor is not as exciting right now, but it will come into play later on. And there's other parts of classes that we'll get to explore later, like Copy Constructor, well, when we do operator overloading, then we talk about operators. So, but yeah, rule of 3 and whatnot. So, yeah, there's a lot of more to classes than what we see so far. But we got to start somewhere, right? So, the one thing though is that the constructors can have more than one constructor in a class. So your default constructor is the one without parameters, which you can't add or gets automatically added. Destructors don't get automatically added, but even if they did, they would just be empty. So maybe they do, but they're empty in the same sense. So maybe. It doesn't matter either way. You don't need them though. Like the code will compile. If it needs to be added, it'll be added for you, but it'll compile. With constructors, you might ask me why you want to have more than one. Well, you might have an object like a car where you just want to create it with some default values. That's cool. But you may also want to have one where you want to create a car, but you want to set some of those values initially to a certain state, such as like maybe you want to create a car where like it's already on. Or you may want to add a parameter in here. In fact, let's do that, called max speed. Like the governor of the car, you know, how fast it can go before the governor kicks in. And so you might want to pass that in as a parameter when you're initializing it. However, if nobody passes anything, then maybe you set a default of 140 miles per hour, something like that. So that's why you might have more than one constructor, okay? So let me see if there's anything else that I want to say. One more thing, two more things before we go into code. Because we still got half an hour and I would like to code. After all, this is a coding class. So the next thing is more of like a vocabulary thing. So let's talk about the different kinds of operations that you might have in here. So we talked about, where's my list? About like accelerating, braking, and whatnot, right? But we also want to talk about accessing and modifying the variables. Now, a lot of these functions do that. Accelerate is a function that will modify something. Lock and unlock is a function that will modify something. It will modify the status of the lock variable, right? Brake will modify the speed of the car, so they'll modify that. Start and stop the car will modify the variable that keeps the status of whether it's on or off. So all these functions are technically functions that modify. So we give that as a name to these type of functions. We call them, you know, like modifiers. There's another type. Actually, there's more than modifiers. Some people also call them setters and mutators. So that's, geez, I almost forgot. That's the whole reason why I'm trying to tell you this is because there's multiple definitions of the same thing. Okay? So modifiers and setters and mutators. All of these things stand for functions that will modify class variables. Okay? As you can see, they all sound similar. Like modifier modifies, setter sets, mutators mutate, right? So they're interchangeable terms. There's another class of functions that also exists when you're working with classes, and we just didn't happen to have any. So and they're called the accessors or getters. So let me give you a couple of examples of those. So maybe what we do is let me bring this up here so we have some space. So an example of that would be something like get speed or get current speed. Sounds nicer. Or maybe get status. Maybe that one returns like whether the car is on or off and whether it's locked and unlocked. And get current speed returns your current speed. So you don't have to, but if you put the word get in front of them, it's a good way to kind of indicate to somebody that this is an accessor function. So again, we call these accessors or getters. At least those are the two names that I'm aware of. There might be more. Okay? We have a question. Why would you not just use the .access operator in the struct to modify variables? Okay, that's a really good question. That's like meta, actually. I wanted to talk about it at some point, so might as well talk about it now. So the answer to your question is twofold. There's the short answer and the long answer. The short answer comes with a very popular word, which I actually have a link in Canvas, so you can read an article about it, and it's called data abstraction. Another term that you hear is information hiding. Okay? So I'm actually glad this is coming up because we can get this term out of the way. So thank you for asking this question, brother. This is great. It's like this is flowing now because of the questions. So let me talk about what this is. So as you can see with the setters and the getters, basically you might be asking yourself, why do we need a function called getStatus when I can literally just use the member access operator to print out the variable? Or why do I need to have a function called accelerate when I can just like change the variable, right? So you could literally do all of these things with directs, and you are absolutely correct. And in fact, as long as the variables are public, you can do it. So this comes into the concept back of object-oriented programming as a doctrine, okay? The long way of answering this is to say the following. And I don't necessarily, well, no, I do agree with this. I'll say I agree with this. And it turns out that as controversial as it might sound, there's a lot of bad coders out there, and there's a lot of not so smart people out there. Okay? And that's not to say that, oh, I'm really smart, so I don't run into these problems. I run into the same problems where I would classify myself as a dumb coder sometimes. Okay? The idea is you want to write code that is foolproof. You want to write code that is hard to break. And when you're working as part of a team in a company, a lot of people are going to touch your code, and you're going to touch a lot of people's code. And like, it's just going to happen someday, and don't feel bad. You're going to break somebody else's code, and it's going to break the entire project, and you're going to look like a fool. It happens to all of us. You move on, that's it. We need to have some safeguards to avoid that as much as possible. And so that's the idea where information hiding and data abstraction comes into play. Data abstraction is the concept of saying, okay, I want to make this code be as foolproof as possible. So instead of having a function called set speed or like increase speed, I call my function accelerate or decelerate, or lock my car, unlock my car, versus like change lock status. Idea of that is that you want to make your code easy to read and self-documenting. You know that a function called accelerate is going to accelerate a car. Instead of having to find a function that's called like change speed variable of car, right? But that again goes to the same question. Why not just modify the variable? Turns out that when you're developing your classes for somebody else to use, you're doing your class, so you have two things. You have your class declaration, and then you have your class definition, and then you have you actually using the class, right? Your code. We sometimes consider the class declaration and definition to be the server code, and then we call the code where you're actually using the classes to be the client code. The people who develop the server code are not the same people that may be using the client code. That's like if you use a library that was developed by somebody else, such as if in the first assignment you use the sort function for sorting. That's not something that you created. That's something that somebody else created. Somebody probably much smarter than all of us created, or at least with more experience. And so, while the fact that you're using the function means that you know C++, at least to some extent, and you have some programming experience, at least to some extent, you can still break things really easily if you're not careful. And so what we do is, when we're developing those classes, we limit how people can access them and how they can modify them. Why do we do that? To make them more robust. To make it harder for somebody to take my code and break it. Okay? Imagine that I gave you the solution for the Unigram assignment, and I said, okay, here's a class called Unigram with all the functions in it that you need, and here's a class called Bigram with all the functions that you need. All you gotta do is literally write a main where you call a specific function like print menu or generate unigrams, sort unigrams, and whatnot. All you gotta do is do the main function. You get all the other code. I guarantee you that unless you make that code super like robust, people will do things to break your program. Like they'll manually go in there and like modify a variable called count that keeps the size and the number of unigrams. Like when they shouldn't. They're like, oh, you know what? I'm inserting a unigram. Maybe I should increase the count variable. And you do that when it was done already by the program. And now the thing is broken, right? So there's a lot of ways that you could break somebody else's code and then blame them for it too, which is the best part, of course. And so this comes into introducing the idea of private and public. You want to make some variables private in that only members of a class, so functions inside the class, can modify them, such as the accelerate variable. So you don't want anybody to ever modify the speed variable directly. You want to do it through functions that control how that's done, to accelerate, to decelerate. Maybe you have also safety checks, like you can't change the speed variable unless the car is on. So you limit that. You limit access to that. That's the whole idea behind information hiding, and that's why you don't want to do that. So I know that's a really long answer, but like it's necessary to explain that. It's done to avoid people breaking your code. You only limit them to using what they should. When it comes to the sort function in C++, you can call sort all you want, but you're not allowed to modify internal variables that help the sort function do its job. Because if you did, I guarantee you that either you or I would break it. So they do that. So yeah, and that's the beauty of object-oriented programming, is that having that in there makes working with others a lot easier, because now it becomes a lot harder for somebody else to break your code and then come complaining at you like, oh, your code doesn't work. Well, yeah, that's because you shouldn't be doing this. You shouldn't be modifying the variables. Just call the functions that I gave you, you know? And so that's the whole idea between public and private. So let's talk about that for a second. Public, protected, and private. These will identify whether a function or a variable inside a class is accessible to other parts of your program. Okay? So you split this into three. So we have access inside a class. We have access outside a class. And finally, we have in a derived class. We're not going to fill in that last column of derived because we have to talk about inheritance for that. So we will revisit this next week or Wednesday maybe. But we can talk about the first two columns. So whether a variable is declared public, protected, or private, and by the way, I uppercase them, but they should be lowercase. Otherwise, I don't think the code will compile. So by the way, they're called reserved keywords. If you remember reserved keywords 1 through 5, that's things like the word if. You can't make a variable called if because it gets confused between that and the actual if of an if statement. At least in C++, and Python, it like forgets about that and lets you do whatever. You can make an integer called if, or you can make a float called string. Yeah, but anyways, Python. I love Python, but that's kind of scary. Going back to C++, they're reserved keywords, so don't create a variable called public. If you ever did, you probably ran into a problem. This is why. So inside a class, you can access anything you want. You can access public variables, you can access protected variables, you can access privates. Okay? For all intents and purposes, protected and private will work the same way until we talk about the derived stuff. Okay? So don't worry too much about the protected category. It's just both this and this we'll come back to next time. Okay? But I want to list it here because then I want to fill it in next week. When it comes to outside the class is where the thing matters. A public variable, such as the ones found in structs, or if you write the word public in a class, are accessible outside the class, which means that you can do what you were asking. You can actually access the variables and modify them directly. With a private, you cannot, and that's the power. Because now, you don't let people modify things they shouldn't, but still get to use the useful stuff. So they can still use my car class, they can accelerate, they can brake, they can do all these things, but they don't break the stuff that internally makes this work. And then complain to you. So that's there. It turns out for protected, you can also not access it. Okay? That's it. If you're really curious about derived class, I'll tell you that this is what it should look like. I'll put them in tiny because we'll update them later. Check, check, and then extra. Okay? So that's what it would look like for that. But again, this third column and the protected one in general, we'll talk about it in the future. Okay? So where do you put this public, private, and protected? You put it right here where you're about to see this gray box. By the way, remember, C++ is white space insensitive, which means that you can tab things, space things however you want. So I'm only doing tabbing as I would do it, but you could do it differently. So you would literally write the word public right here like that. You could also write private or protected. If you don't write anything, by the way, the default will be private. So if you just want to keep something private, you don't have to fill it in. I do encourage you still to put it in because it makes your code a little bit clearer to read for someone that might not remember that. And you can switch back and forth. So like, let's say that you wanted the second function to be private. Although technically this is a constructor, so you don't want to... actually, well, you can make the destructor private, but as long as you don't do inheritance, which again, but yeah. It's sometimes, you know, you want to talk about things you're going to talk about in the future, but if you do, then it'll make things more confusing. So I have to censor myself. Okay? So that will be an example of making something private. You can do this for functions and variables. Why would you do it for functions, you ask? Because it's like, the whole point you said is like, you know, you want to have these functions. Well, again, some functions you may want to make accessible to anybody to use, but some you might want to keep internally. So like, for example, you make a public function called sort, but internally you have another function that actually does the sorting. And so the public one is only kind of like the front of the product. But behind the scenes, you have all the nasty stuff going on. Okay? When we get to more advanced programs like a linked list or something, you'll get to see this in like real case scenarios where you have like some things you want to keep private, some things you want to keep public. Okay? Again, this whole thing is there because humanity is not perfect. If we were all perfect, we wouldn't need to do this. Again, like I said, and I will keep saying a lot of times, is what you learn in 135 is enough to code whatever you want. All this stuff is only to make your code better, to make your code faster, to be able to work with teams faster, to improve your overall experience with C++. This is an example of that. Okay? So that's that. Going back to accessor and getter, just to make sure that we all understand that. You typically want to put the word get in front of them to make it clear to somebody that they're accessors. So sometimes you want to be able to have somebody access a variable but not modify it. So you make it a private variable, but then you put a get function. So like, we don't want people to modify the speed variable directly, but we do want people to be able to read it. So like they can print it out to an odometer. So you do a get current speed function. On the other hand, you know, you want a variable to be both modifiable, like you want to be able to lock something, and you want to be able to see whether something is locked or not, right? If we're talking about like the door lock, the status of the lock unlocked. You still don't want to make the variable directly modifiable because it doesn't look pretty. It doesn't look cool. If you make a function called lock your car or check lock status, that's more self-commenting for somebody that is using your code than to trying to modify the variable directly. Even for variables that you both modify and access, you still make it private, and then you just make the functions like called modify or set, and then your get. Okay? So I know this all seems a little bit like sus for you, like, yeah, this seems like a lot of overhead, but I'm telling you, people do this because it's actually clearer this way. If you think about 135, you probably got to use a size function, right? With a string. When you want to find out the string, like how big a string is, you know, you probably if you have a string called like A, and you want to find out how big it is, I think it's A dot size or A dot length or something. A dot length. It's one of these two for that. Or if you're talking about length, well, one person said size, one said length. Both exist? Oh, both exist? Oh, okay, cool. So you might be asking, okay, well, why don't they just have literally like A dot and then like a variable called size? You know? Because it's not cool. It's way cooler to do this, right? It's a lot cleaner. And plus, you can even have like multiple functions that give you the same thing back so that people like me who don't remember can still use it, right? So that's an example of like not me coming up with this, but like this being a real thing, even for something as basic as a string class. So hopefully I convince you about that. Hopefully. But if not, then you will convince yourself as you practice more coding that this is a good way of doing things. So that abstraction, encapsulation. That's one more time. We might not get to coding today after all, but that means we'll just do all coding marathon next class. Let's talk about encapsulation. That's another term that is good to know. And then UMLs. So encapsulation is, we already talked about this in a way. That's the idea of putting data and operations in one class. So I'm going to give it the informal definition of combining data and operations on that data in an object. Okay? So it's again basically what we're doing so far. So basically putting everything in a bucket of data and operations, and it just has, I'm just giving you the term for it because it turns out that the three major trifecta of object-oriented programming are encapsulation, data abstraction, and a term that I think I used the other day called polymorphism. But we'll revisit that later on, okay? But those are the three principles of object-oriented programming: encapsulation, data abstraction, and polymorphism. I don't want to put the word data in there because it technically could be also functions. So, yeah. Okay? So now you know what OOP is, right? When should we start working on the next assignment? Probably not until Wednesday because you might get confused otherwise. But I was told by Ed that the second assignment is very easy, at least compared to the first one. So we'll see about that. And I've also been talking to him to not overlap them. So since the next assignment is not due on Tuesday, maybe we'll make the next assignment due on Wednesday of next week. So you also have a week after the next class to do it, even though it's easier and shorter. So don't worry too much about that. But yeah, those are the principles of that, okay? And on Canvas, by the way, oh yeah, that's true. Yes, but I don't want to talk about that one yet because you don't also know what it is. So now that you mentioned it, you spoiled it for it. But yes, there is also in here inheritance. But then you're going to be like, what's inheritance? So for now, we're going to hide that. And then I was going to throw it in next time or next week. But yes, that's why I did circles and not pillars. Let's go with that. What do you mean the second lecture? This is the third lecture. The second one has already uploaded to YouTube. Both lectures from last week have been uploaded already. If you look at the playlist that I have, they will always be there. So the first two are up. And then the third one, which is this one, will be up tonight. Like 2 a.m. probably or something. But yeah. I'm glad that you know all this about inheritance, you know. Like, did they cover that in 1 through 5? Did they actually show you inheritance? That would be pretty impressive. Oh, so you just happen to know it? The lectures will be on Twitch, but you will be able to access the recording on YouTube. So we will no longer use WebEx at all. So, yeah. Yeah, we only got 8 minutes left, so there's not really much in me trying to code a lot. Although we could start, but I'd rather talk to you about a UML diagram. So, we're good so far on OOP. We only got 3 things. Yes, inheritance will go in there someday, but not today. So, let's go ahead and talk about what UML diagrams are, okay? So UML diagrams I have listed here is a way of representing the structure of a class to someone that needs to implement the class, okay? So like, you know, somebody comes to you and says like, I would like you to create this code. It's hard for them to like explain this. One way you can do it is what I did, which is use list of functions, and it works, it's cool, but it's not very formalized and clean. So a UML is very useful to portray this information in a nice and clean way. And so we're going to actually develop between now and the beginning of next class a UML diagram for this car class, okay? So I'm going to copy and paste it here just so I leave it ready to go for next class. And we'll probably add more things in there than what we currently have. But I would like to kind of make it a nice and beefy example of classes. And maybe when we do inheritance, we modify it. Unify. Very good question. UML stands for Unified Modeling Language. Oh wait, unified? No, universal. Sorry, I think it's universal. Universal or unified? Hold on. Now I'm questioning myself. UML. Unified. So I was right the first time. Unified. Language. Okay, and if you go on Wikipedia, they apparently have a Wikipedia article on it. What's mapped list, by the way? Oh, you were trying to guess what it meant. I see. Yeah, that's very fancy. No, unify. You know, by the way, I think the reason why I probably thought universal tool was because in the past I thought that's what it meant, but then I figured out it didn't, and it's still like in the back of my mind. But I still don't trust myself to be unified. But yeah, it's unified. So as you can see, by the word unified, it's a convention that people are trying to come together with and say like this is one way of representing something, regardless of a language, I guess. And so what that looks like is going to be this, and we're going to do this for a very simple example. In fact, actually, let me take an example that I already have here, and then what we'll do next time is we'll make the UML for the car, and when we finish that, then we'll actually go and code it, okay? Because we only got 4 minutes. It will be a long time to do that for the car. So here's an example of what a UML diagram looks like that I happen to have. This is from, I guess, 202 summer edition or fall edition, summer probably, from my summer class in 202 that I did last time. I guess we were, instead of doing the car example, I came up with some triangles, which is cool too. So the first thing you'll notice here on the top is you put the name of the class. As you can see, I have the uppercase T because that's not a thing I came up with recently. It's just been with me forever. So that's where that comes from. The next thing is you'll see that there's this sort of table is split up into 2 areas. We have this area here on blue, and then we have the area on white beneath it, okay? The area on blue is meant to keep all your field variables. So all the variables that are part of the class triangle. So as you can see, we happen to have 3 variables in this class. We have color, H, and L, which stand for height and length, because it's the dimensions of the triangle. In case you all don't remember triangles, let me get you a picture of a triangle. Hey, picture of triangle. And then this will be like your length, which is the L, and then this is your height. And what's the formula to figure out the area of a triangle? You do length times height divided by 2, right? I hope. Yeah, okay. So, yeah. And, well, yeah, that's always the case. There's never, I was like, is there an exception? But no, there's not. Okay. So, yeah, so you know, we're trying to keep all the information from the triangle. You're keeping the height, and then the length, and then I guess in this case we had a color as well, just to add another thing. And so the formatting of this is very, very picky, and that's what you're supposed to do. So first of all, you'll notice these minuses and these pluses. These are not just lines that I came up with. What those stand for is actually whether that variable or function is a public function or a private function, okay? And I think there's another symbol for protected. I do not remember right now. It might be like an exclamation point or something. Doesn't matter. When we get to inheritance, we'll talk about all that stuff. We'll update our UMLs, basically. And so in this case, it's saying that color, height, and length, H and L for short, are all private. So that's the first thing you see here. That's where the minus is coming from. So this is what I'm talking about. This is the variable names. The colon is just there, always. You just accept it as being a thing. And then here is going to be the type of the variable that it is. So strings or integers in this case, okay? The function side is very similar, except that, as you can see, you are going to have to list your parameters, okay? So you first start out with, again, whether it's public or private. In this case, we have 2 functions, and they were both public. I guess I was going to add some things here, and that's why that's there, but don't worry about it. In fact, here, let's just snap it out of existence. Okay, so that's where this comes from, whether it's public or private. Then you get your function names, which is these, which is, again, we got set length and get color. Oh, I guess these are 2 were probably for like set height and set color. Yeah. I don't know why I never added them though. But yeah, that's the function name. Then you are going to be listing your parameters in there. So you list all the parameter types. Start out, you know, it might be a constant, it might not, but you still put the return type of the parameter, and I guess if you're passing by reference or value. And then you have the return type of the function. Value returning function for get color, because you want to get the color back as a string. And for the set length, it's just a setter or modifier, mutator, choose your name. So it's a void function, okay? That's it. That's what a UML is like in simple. And again, it's an easy way of representing it. So the first thing we're going to do on Wednesday is we're going to take the car class, and we are going to make a UML out of it. And when we finish that and we're happy with it, then we're going to go ahead and code it. And that will probably take the majority of the class. But if we finish, then we will go and do some inheritance or whatever's next. Okay? So that's the class for you. I was hoping we'd code some today, but that's okay. just we'll just have to refresh what the car class does on Wednesday. Because it's good to get all these concepts out of the way. They're important. So, a lot of talking. It's probably going to be one of the few classes we'll have the whole semester where there's no coding in the class. It'll always be coding. But yeah, I hope I was clear and that everything is thorough. If you have any questions, email or Discord, and I'll see you all on Wednesday. Thank you for coming. I appreciate it. Bye, everyone. Take care. Good luck with the assignment.